Hello, my name is Divyang, and this is going to be my presentation for E104 Lab 8. This is going to be task 2, where we detect an object using using AI through RoboFlow. This demonstration is going to include the image demonstration. Thereafter, we're going to have the video demonstration using the webcam. So let me share my screen. So the objective of this lab task was to basically enable an object to be detected by AI. This object can be anything, including a person or a physical object such as calculator, pencil, marker, eraser, baseball cap. But for this particular lab exercise, we're going to use the calculator. So we first create our own pictures by taking pictures of the calculator such that the model can be trained, because without training the model, it will not be able to detect that there's a calculator. So for that, we took our own pictures. We took 60 total images across various angles, because in order to train the model effectively, we want the model to be exposed to different angles, different lighting, such that it can produce a more accurate result when detecting the calculator. So for this particular exercise, we have 60 total images that we're going to be uploading through RoboFlow. I've already done it, but you basically upload it through RoboFlow, and RoboFlow is this application where it provides database management, as well as it's an API tool for image processing and image detection. It's also a processor. It's also a tool where developers can have computer vision applications. But for our usage, we're basically uploading the images such that it can be annotated for processing, and we are able to run the final result through Windows PowerShell. But for now, this part of the video is just going to show you the annotation process. So once we upload the data, we can go to annotate. And right now there's no jobs, but if you click on the previous job that I had, this is the calculator. So we're able to click on it, and as soon as it says Casio calculator, those are the annotations that I made for each of the pictures, each of the calculator pictures. So that's 60, and we split this up into testing, training, um, because for the AI model to detect the calculator, it needs a set of pictures just for training purposes and a set of pictures just for testing purposes. So once we get done with that, we are able to download this folder as a zip folder. So once we click data set, then from here, you're able to download it as a zip folder. And after we download this as a zip folder, we basically have to we have to clone the GitHub repository, which is the analytics repository. This allows us to process the information through the pictures in the calculator. It enables us to essentially have information processing. So that GitHub repository clone is right here. We go to our C drive, and we're able to see Ultralytics. And Ultralytics is basically the name for this folder. It provides data analytics, essentially. As mentioned earlier, for our calculator processing detection application. So for here, we go to data sets. So there are two sets of data sets. One of them is the calculator, and one of them is me, Divyang. So this is going to be for the Divyang set of photos is going to be for the lab group member detection, which is a separate project. But for this one, we're going to take a look at the calculator. And so we're now divided into three folders: test, train, and valid, and data. So the test photos are just images as well as the labels. And for the training images, we have another set right here for training, as well as we have the labels for them. And once we have that, we're able to do a dry run testing on Windows PowerShell. In this case, we basically have to use PowerShell to launch this. You could also launch it using an IDE of your choice, but in our case, we're going to use Windows PowerShell. So let me just restart the PowerShell. And then you run it as administrator. Then you copy this command. This enables us to, we're basically telling Windows PowerShell to access this folder and run the pictures that we downloaded from RoboFlow, and we uploaded to our C drive in that GitHub repository Ultralytics folder. It enables us to leverage the YOLO application in order to run the detection. YOLO is basically an object detection algorithm, and YOLO stands for you only look once. It's a kind of a spin on the name, but it essentially enables us to have the algorithm for object detection. So now when I click it and I enter the command, we are going to be able to see the images. So that's the Casio calculator image detected, and that's the end of that simulation. If you want to just run it again, just for better clarity, it takes a little bit of while, but bear with me. The YOLOV version 8 summary, that's the version 8 of this object detection algorithm. And so you just saw the calculator. And for the next part of this video will be the live video demonstration. So thank you, and stay tuned to that aspect of the video. Thank you.
Hello, my name is Divyang, and this is going to be Lab 8, EE104. This is going to be the demonstration for the AI detection for the object. This is going to be the basically the third task for the Lab 8, and this is where we detect the Casio calculator using AI. And as you can see, it's currently being detected, but we have trained this model to detect the Casio calculator. So as you can see, the percentage at which it calculates, the accuracy is fluctuating. We've fed it 100 epoch models, which are basically data packets that we feed into this model to train it. And as you can see in the scrolling menu on the left side, it is in fact detecting the calculator. Furthermore, for this lab, we've used RoboFlow for the labeling and processing of the images, such that we can export it into our C drive, and from the C drive we're able to run analytics, which is basically a software that enables AI detection for objects as well as people. But for this task, we're going to be detecting a specific object, which in this case is the Casio calculator. So as you can see, it is detecting the calculator, and this has been the task for Lab 8, object detection. Thank you so much. In the video just before this, it will be a thorough explanation of the process to get here, but this is just a live demo for the detection of the Casio calculator. Thank you so much. Have a great day. Bye-bye.